So hello, my name is Vitor Pereira. I am a water supply networks manager at Águas, Douro, Paiva. Currently, I oversee the operational management of 240 kilometers of mains, and this includes reservoirs, pump stations, chlorination sites scattered around 9 municipalities in Porto region. And these facilities, they consume a lot of energy. For us, for the water sector and for Águas do Paiva, energy management is really critical. Just to put it into context, more than 60% of our external supplies and services are related to energy consumption. So, besides environmental, this is an issue of financial sustainability too. In our strategy for energy transition, we focus on two main pillars. First, the efficiency. And in efficiency, when we talk about the pump stations, as they consume nearly 90% of our energy, we focus on pump station optimization of efficiency. And in fact, Águas do Paiva, according to the Portuguese regulator, is the leading water company in pumping efficiency. We have nearly 550 kilometers of networks, so and our water loss levels are 1.5%. So also between the best benchmark values of in Portugal. And just to give you a context on the importance of the water energy nexus in the water sector, if we lose an additional 1% of water, that will mean an increase in 1 gigawatt hour of energy each year. These systems, for us, they can be a real game changer, as we are already incorporating renewable energies in our operations. In fact, that is the second pillar of our energy transition strategy, is the production of renewable energy in order to get more autonomy and an increased self-production of green energy. We already use AI in our operations because they not only manage the system to supply the municipalities, but they also optimize our scattered solar energy production in order to maximize the use of renewable energy. We started with solar energy, and in 2025 we produced around 3 gigawatts of energy. We are on the way with our plans, and we will reach 10 gigawatts per year. We also have in place wind power project, and with the new wind power, where we can reach an additional 10 gigawatts of energy. And the hydropower, which we are in an earlier stage, and that is why we are here today to learn lessons from this project and how we can strengthen our renewable energy strategy. We are already at a very high level of efficiency in water, but our infrastructures, they are aging. Right now, they are reaching some 30 years of lifespan. So from now to the future, if we can remain on that 1.5% of water loss, it would be great. In fact, with the data and with AI, it will be easier to identify possible new leaks. I think one of the challenges will be in a possible scarcity of human resources, of skilled and qualified human resources, because especially in the repair of big diameters, it can be a complex task. It demands experience, it demands hard work, and nerves of steel during those operations. So that, I think, would be a challenge. But the primary challenge, I think, it will still be to have a sound engineering, hydraulic engineering supporting the systems, because the systems, they are dynamic, they are alive as the consumption patterns, they change, and we have to adapt, and we have to prevent problems like water hammer, like cavitation, and this is key for reducing failures, reducing bursts, and in order to extend the lifespan of assets. Adding on what I said before, as we have more AI and more data, that data will be useful for optimizing our operations and prevent problems. But besides the human resources, besides that sound engineering, we have a particular risk, and we have to manage that risk in the water sector, because we have a great gap between the identification of a risk and the implementation of a solution. Between identification, designing a solution, getting the licenses, the public tenders, and the works, it can be from 3 to 5 years until a solution is on the field. So we have to have a very robust management risk system in order to identify today what will be our problems from 3 to 5 years in the future. And that is key to resilient systems.